This video I would like to introduce a very nice problem of Belarusian Mathematical Olympiad 2007. Here is the following information. Find all positive integers n and m such that we have this following equation: n to the fifth plus n to the fourth equals 7 to the m minus number 1. Okay, in fact this is very nice and interesting equation to work on. The issue with this equation, we have two unknown variables. We have n and m. The left hand side of this equation involving n, and the right hand side of this equation involving m. Okay, so as usual, to solve this equation we must transfer this equation into the product. Okay, so if you would like to give that try to this problem before you get into the solution, go ahead, pause this video when you come back to see the flow. Now let's get started. We have this following equation. We have n to the fifth plus n to the fourth equals 7 to the m minus 1. So I'm simply going to bring this minus 1 to the left. I will get n to the fifth plus n to the fourth plus number 1 equals 7 to the m. Okay, it seems hard to factor out this expression, but we are going to use some tricks and you get this expression factorized. Okay, so I'm going simply to put this one as n to the fifth plus n to the fourth plus number 1. I'm going to put n to the n cubed minus n cubed plus n square minus n square plus n minus n. Okay, like this equals 7 to the m. As I did nothing, just I'm adding one term, subtract the same term, and so on and so forth. Okay, I'm going to rearrange and group these terms. I'm going to group n to the fifth with n cubed with minus n cubed. For this term, n to the fourth, I'm going to group it with minus n square. For n cubed, I'm going to group it with minus n. Okay, plus n plus number 1 equals 7 to the m. Okay, now I'm going to take I'm going to factor out the first. I'm going to factor out the first term by putting n cubed as a common factor. For the first term, I will have n cubed is multiplied by n square minus 1. For the second one, I will have n square is multiplied by n square minus 1. For the third one, I will have n is multiplied by n square minus 1. For the last one, we will have n plus 1 equals 7 to the m. Okay, I'm going to leave this one as is, plus n square. Okay, because I didn't put it here, because here is another term which is n square here. Now I get n square minus 1, n square minus 1, and n square minus 1 as a common factor. So we'll have n square minus 1 factor n cubed plus n square plus n, okay, like this, plus the other terms, which is n square plus n plus number 1 equals 7 to the m. Okay, I'm simply going to take n out of this parenthesis to see what's given us. N is multiplied by n square minus 1 factor n square plus n plus 1 plus n square plus n plus 1 equals 7 to the m. Okay, now here is n square plus n plus 1 as a common factor. I will put n square plus n plus 1 factor is multiplied by the first term, which is n cubed. By multiplying this one by this one, I will get n cubed minus n plus this one is multiplied by number 1. Okay, equals 7 to the m. Now we have ended with a nice product here. Now we are going to discuss this product. The right hand side of this equation is a power of 7. The left hand side of this equation must be a power of 7 as well. But here is the issue. If you are going to solve this one by using this product as a power of 7, you will find a problem. Okay, you will find two different equations. When you try to get rid of one of these variables, it will be hard. Okay, because the reason why you put this two equation system to get most of the terms cancelled. Okay, but in this case you don't get all the terms cancelled, so we'll find with this n cubed and n squared. So it's hard to find these variables because we have m and n as variables. Okay, so what to do? I'm going to go through the GCD. Now let's bring this one at the top and move forward. Okay, now we have ended with this expression. Let's set d equals GCD, the greatest common divisor of these two terms, which is n squared plus n plus 1 and n cubed minus n plus 1. Okay, so our goal, we are going to find the GCD of these two terms. Okay, if you find the GCD of these two terms, that means we find the GCD of this one, because they have equality here. Okay, and notice here this is a prime. Okay, so now I'm going to calculate the GCD. Let's find GCD. We know D divide this one. D divides this n squared plus n plus 1, because it's GCD of this one. Okay, if this one divides this one, that means D divides n cubed minus 1, because we have n cubed minus 1 equals n minus 1 factor n squared plus n plus 1. Okay, if the GCD D divides the small one, that means D divides the big one. Okay, because this one is a multiple, because this one is a multiple of this one. Okay, so which means, according to the divisibility statement, so which means n squared n cubed minus 1 is a congruent to 0 mod D. Okay, like this, because D divides this one. So in the other word, equivalent n cubed is a congruent to 1 mod D. So here is the first statement. I'm going to look for the second statement. I'm going to use this side now. So we know D divides n cubed minus n plus 1, because they have a common GCD, because they have the common GCD. So which means, according to the divisibility statement, you will have n cubed minus n plus 1 is a congruent to 0 mod D. Okay, by taking minus n plus 1 to the right, I will get n cubed is a congruent to n minus 1 mod D. Okay, the same equation system. So we have n cubed is a congruent to 1 mod D. At the same time, we have n cubed is a congruent to n minus 1 mod D, which means I'm going to combine these two equations. I will get n cubed, which congruent to n minus 1, which congruent to 1 mod D. Okay, by taking the one to the left, I will get n minus 2 is a congruent to 0 mod D. Okay, this one is telling us D divides n minus 2. Okay, what does this mean? This one is telling us n equals 2, because if you replace n with number 2, we'll get 0. That means D divides 0, which is correct. Okay, I'm going to replace this value of 2 into this product to see what's giving us. Okay, so we'll have 2 cubed plus 2 plus 1 factor 2 cubed minus 2 plus 1. This one is giving us 4 plus 2, which is 6, plus 1, which is 7. The second product is giving us 8 minus 2, which is 6, plus 1, which is 7. Okay, so we'll get 7 squared, which equals to 7 to the m. Okay, notice here n squared plus n plus 1 equals D equals 1 or 7. Okay, as we said before, because we have 7 as a prime, that means 1 divides 7 and 7 divides 7. For D equals 1 doesn't work, because we have the positive integers. This one is bigger than 1. This one is a root out of this possibility. That means that GCD equals 7. This means D equals 7, which giving us this solution: n equals 2 and m equals 2. Okay, this is for n equals 2. Okay, let's check when we have n is super equal to 3. For n is super equal to 3, this term n cubed minus n plus 1 becomes strictly superior than this term, n squared plus n plus 1. Because when we have n equals 2, we have equality. This one equals to this one. This one is given as 7, this one is given as 7. But when you have n is super equal to 3, it's giving us this one is bigger than this one. So since the right hand side of this equation is a power of 7, that means the left hand side of this equation is a power of 7 as well. So which means n cubed minus n plus 1 equals 7 to the j, and n squared plus n plus 1 equals 7 to the I, where is j strictly superior than I, because we have n is super equal to 3. Okay, that's mean when you have n equals 3, this term become bigger. Okay, that's mean this I, that's mean the exponent of 7 become bigger as well, which means the GCD of these two terms become super equal to 7 squared or 49. Okay, because when I have n equals 2, it was 7 here, which I equals 1. Okay, but when we increase in n up, n is super equal to 3, this one also become bigger, which means that the GCD of this one become bigger, become 49, which is contradiction, because we have GCD equals 7. Okay, now we have no solutions for n is super equal to 3. So the only solution that we found when we have n equals 2 is giving us this solution. So I have done this problem. If you are interested in this one, don't forget to support us with your like and subscribe. Thank you for watching. We'll see you next video. Bye.